Hello, welcome to Electronics Education. I'm Vincent Chang. Today we are going to continue the small signal analysis for MOS transistor amplifier. MOS common gate amplifier analysis by inspection. Here's the common gate amplifier circuit. It's the grounded gate configuration for MOS. So gate is AC grounded and the signal comes in through the source terminal and output is taken out from the drain terminal. And then for the input impedance or input resistance, looking into the source. So between source and the ground, and then between source and that ground. So what do you see? So it's the parallel combination between the RS and the 1/over transconductance. So how about the small signal voltage gain? Small signal voltage gain, VO over VGS, and then times the VGS over VI. So VO over VGS, the first term, VO over VGS is negative GM times the parallel combination between RD and the RL. And then, so based on Ohm's law. So how about VGS, the second term, VGS over VI? Is the divider, is the voltage divider, based on a voltage divider between which one? The source resistance, I mean the source means the signal source, the R, and the RS. So R and RS. RX in parallel with 1/GM. So R and Rin. So Rin divided by the total series resistance at the input side. So see, I almost make a mistake, right? So pay attention to the input resistance. It's not just the RS. So between source and the ground, and between source and the gate is grounded. So between the resistance between gate and the source, looking at the source is 1/GM. So the input resistance is the parallel combination between those two, 1/GM and RS. So take the input resistance Rin and going to be divided with the R, And the two negative, because the VGS is negative, is the negative VGS. So the first negative and the second, the negative in the first term, I should say this, and the negative in the second term got canceled out. So it's the in phase, the gain is positive. How about the output resistance? It's the RD, right? It's RD, easy. So this is the three important amplifier parameter has been obtained based on the analysis by inspection. So now let's go a little bit lower. So from the small signal equivalent circuit. So VI, R, and RS. And now source gate drain, T model. The resistance between source and gate, looking at the source, is 1/GM. Voltage across the gate and the source is the VGS. So voltage control and what? And the current source. So voltage control, current source, the GM VGS. And the resistance between drain and the ground are two. There are two. Now one is RD, the other one is load resistance. So the first parameter, the first performance parameter, amplifier parameter, is the input resistance. It's a parallel combination between, again, the two, the RS and the 1/GM. And the second one, the small signal voltage gain, is based on the Ohm's law and the voltage divider rule. And then it's the product, all right? And then the last one, here's the last one, is RD. The output resistance is simply decided by RD. So how about VGS, the GM VGS, the current source? Because when you set the input signal source as 0, So VGS is forced to become 0. And then the voltage controlled current source becomes 0, so which is equivalent to open circuit. Again, the analysis by inspection to solve this. The input resistance, a small signal voltage gain based on Ohm's law and the voltage divider rule. And the last one is the output resistance. I hope this kind of repetitive training to help you really boost your confidence and get you familiarized with those transistor amplifiers. So this is the end of the lecture, also the series of the MOS, the end of the MOS amplifier series. So in the future, I'm going to teach you, because this is the low frequency or medium frequency analysis. So in other lecture video, I'm going to teach you how to deal with the capacitance, how to deal with the amplifier frequency response. I hope you in the future. I hope we see you in the future. Thanks for watching.